Hello and welcome to another edition of Google Developer Group Workshop. Today we'll be looking at building secure AI agent in Go. My name is Nguuma Tyokaha. I'm an AI developer specialist. We will start by understanding what an AI agent is and look at how to deploy or build an AI agent using Go. An AI agent is a software designed to autonomously perform tasks, making decisions, and interact with its environment to achieve specific goal. Look at an AI agent as a system that follows the framework called React. That's reason and act. What AI agent does is it looks at the user's prompt or the input. It reasons, it goes through it, understands it, and then it acts upon that that request. Um, in a simple chatbot system, AI agents operates differently. AI agent can actually do two calls, which these two calls can be search the web, do mathematical calculation, call API, and also even control our computer or system in its environment. Let's also look at, in this slide, we'll be looking at a simple diagram that illustrates how AI agents work. Like I said, a user gives in a prompt. Here we are looking at multi-agent. So we have a supervisor agent. We have agent 1, 2, and 3, and then the agents also have capabilities of two calling. This AI agent 1 can be an AI agent for weather, agent 2 can be a digital marketer, and agent 3 can be a business analyst. This agent can have their own tools to carry out their various tasks. Like for the weather, it could tell you temperature, could tell you if it's raining tomorrow. You could have the access to calling different APIs for weather information. And then when they do that, they get the information, send it back to the supervisor. The supervisor understands and then presents it back to the user. This supervisor, before even calling or before even transferring the information that the user has given to the AI agent, he has the knowledge of what this AI agent can do, and that's how it decides to understand which AI agent is supposed to handle what task. So in this workshop, we will be using Go. Go, it's a very um, impressive programming language. It's been Go was developed by Google and it was released in 2029. Go is an open source programming language that makes it simple to build secure and scalable systems. Most of the systems we are currently using are being built on Go. Systems like Docker, Kubernetes, Terraform, and most other platforms, like also part of Instagram, are being built on Go. Go is known for its simple syntax, which is readable. You can easily read programs in plain English, unlike other programming language as well. Go is very fast. It compiles very fast, and that's another very strong feature of Go. It has its own built-in concurrency for Go routine, which can actually run multiple channels and make parallel work effortlessly. Go is a static type programming language. It catches bug at compile time, which allows us to write less boilerplate. Go is also cross-compiled programming language that can be run on Linux, Windows, Mac, and any other operating system. Go has a very strong community, and it has very impressive and large and also strong standard libraries. It has a very good growing ecosystem, and we have, like we all know, the Gemini right now is one of the strongest model out there. Go has Gemini SDK. It has its own framework called Enum, and it also supports LangChain. These are frameworks for building AI agents, and Go it is built to be production ready. So in this slide, this is a very simple Go code here. I think we will not go deep into it now. When we move to the demo, we'll illustrate how we could write our first Go program. This is also as this is how we write or we call Go, sorry, Gemini API using Go. And talking about building secure AI, there is an there is a community that have actually helped us generate a checklist, and this checklist is what we'll be using to build secure large language model or AI solutions in modern world. The organization is known as Open Worldwide Application Security Project. They released the first OWASP large language model top 10 in 2023, and it was updated in 2025. This checklist helps us to build secure AI as developers, architects, and security team building AI solutions. So this is the checklist of the security checklist, or the risks, the top 10 risks in building or integrate or adopting large language model. So in this workshop, we'll be focusing on just three because of time. We'll be looking at prompt injection, sensitive information disclosure, and then excessive agency. So when we move to the demo, we'll be illustrating this checklist. So why do secure AI agent or AI agent matters for Go developers or AI developers? AI agents have real-world agencies, which allows us to do tool calling. We could read, write memory, and access data and this AI agent can access data on our behalf as well. Also, talking about security, a vulnerability or a vulnerable AI agent running locally on your PC can still leak sensitive information, because most people say building AI agent locally, you might end up not exposing sensitive data. But this research have proven that even locally, you could end up also exposing sensitive information from your system out to the public. And that's where we'll be using the OWASP LLM top 10 to actually be able to build a secure system of a secure AI agent. So let's just jump straight to our demo. So in our demo, we'll first start with this is my terminal, my code. We'll start with the introduction to Go. So we'll have our first Go code, and in Go, your first entry point for Go program is main.go. That's entry point for any Go project. And for us to understand the syntax in Go, um, input here are some of the packages we have. So this FMT, it's format, right? So if you want to format your output or print output in Go, this is how we end up printing in Go. So Go functions can take multiple input as well. Here we have an input as a, an integer, and then another input as b, which is also an integer. And this is how you return a plus b. For and this is how you write a Go function. So here we want to have like a greet function that says hello, my name. So this is how we do that in Go. We'll also be looking at this is how to print in Go as well. You could do like a simple print. And then for Go variables in Go, this is how we write variables in Go. We call it var. You give it a name and then the type. Here we have string, and we still have the same types we have in other programming language. We have int, string, float, boolean, and this is how we have string in Go. This is how we have input in Go. This is how we have float as well. So in this simple, for you to run your Go program, we need to do Go run, because we're actually in this folder. We have different folders for the demo. So in programming, we start counting from 0. That's why we have the demo 0 here. So great. So just run my first Go code. Just expand, increase this. So this is our first Go code, and here it actually showed the Go. We're actually using Go. We are trying to add 10 plus 32, which gives us the answer. And remember, we're trying to also print hello Google Developer Group, GDG Developer. So, and then we were trying to have a score if, and this is how we have if statement as well in Go. So we're saying if the score is equal to 75, right? Shows that the user has passed. So here, this is how we have the if statement. If the score is greater or equal to 50, we should print this score 75, you pass. So this is just how we have a simple Go program. So we'll just go right away and clear our terminal. So we have new space, and then for the demo two, the second demo, we will be looking at actually communicating or writing a Go, building an AI chat system or an AI text system using Gemini. And for us to do that, we first of all need to get our API key. And for you to get your API key, you need to have a Google account. Come to your Google AI Studio. You can always create your API key here. Once you create, copy the API key, and then never put your API key in your inline code. Always try to put your API keys in your .env file. That's another secure way of building building on AI, so you don't expose your credentials. So here, remember we talked about packages. So this is how we end up using packages in Go. You import them here. We have context, we have format, log, the OS, and we have Golang to be able to call Google Gemini AI model. And for us to be able to get the credentials, we need to also use the package called go.env to load the API key. So this is how we load the API key in Go. And Go in Go, you have a lot of error handling in Go. I think that's almost a complaint about Go. So in Go, we do a lot of error. We try to catch error in at hand. So if error is new, we will now print or log this error. If there's no error, then we can now call or get the API key. And also, if the API key comes with an error or is not in our .env file, we could also log this error here as well. So moving forward, this is how we also call. This is context in Go. This is how we call the module that we want to use. So here we'll be using Gemini 3 Flash Preview. See, in Go programming, we use a lot of errors handling. And like I said, for printing, this is how we end up printing in Go as well. So let's just run this here to see the result. So I have my API key in my .env file. We're expecting for it to hit the Gemini 3 to be able to give us our response. So here, what we are trying to ask the AI, this is the user prompt here. In one sentence, why should developer learn Go? So this is the question. And then we also want to print the answer that we get from Gemini. So here we have Gemini. This is the response from Gemini. So we have developers should learn Go because it offers a powerful combination of high performance, minimalist syntax, and native support for concurrency, making it the ideal language for building scalable modern cloud native system. So we're just being able to communicate with our online our cloud-based Gemini model. So in this workshop, I'm not just going to be showing us how to use cloud AI or frontier models. We'll also be looking at downloading um, local models. And the good thing is Gemini just released their new models called Gemma 4, which we can actually download locally and use it on our devices. So in places like Nigeria, where we understand the issue of internet, we have power and all that, the resource constrained environment, using local models like this can help us build sovereign AI solutions or applications in Nigeria. So in our next demo, we will be looking at having to download the GML model from Olama, and this is how we could get the model from Olama. First of all, we need to do Olama. I've already downloaded this model already, so it's locally on my PC. So you first of all install Olama by going to their official website link here. I'll be putting this demo in on Git so you can actually access this code as well. So you can just go to the website and then download Olama based on your operating system. And once you do that, you could just have the Olama being installed. And Olama comes with varieties of local models like Queen, most of the open source models. But for we will be pulling GML for 2 billion parameters. So that's what we'll be using here. Already have that in my PC, already on my PC locally. So for we to test that, I'll be running this in my terminal to see if we have the model. So here, like you see, it's trying to get the response from GML4, which is actually local on my PC. So this is actually local. Perfect. So we have confirmed that Olama is running and then GML4 is also running. So in our next demo, we'll be using this local model to build an AI agent that has access for tool calling. Here we'll be giving the AI agent instruction as an AI farming agent with multiple agent tool calling, and then we'll be using SQLite to have it to make the model have the AI agent have memory. So why should they have memory? You want the AI agent to be able to remember its conversation or last context that it has. This will help you build more user-friendly or robust systems as well. So we'll be having different multiple agents that will be doing different tasks. We'll have AI agent for that understands um, our location, that understands the agricultural price of yam, price of some of the crops we have in Nigeria. So just run this by running the AI agent 2. Let's just get that my readme file. So everything is here in the readme file as well. All right. So it's very straightforward. You just follow this as well. So I'll just get that from my readme file. So we'll be doing to avoid too much typing. Yeah. So you could also vibe code this as well. You could give the AI an instruction, either use Claude or anti-gravity or any of the AI tool to be able to vibe code this as well. So here we're going to go run dot, go to the folder, and then we'll be running this agent. So let me just increase this as well. So this agent, this multi-agent system has access for supervision, have access for multiple sub-agent and tool calling. So here, what this AI agent does is we've been able to give it instruction as well. So the instruction here, to show you, so I don't need to go too deep in this code. So we're using my SQLite to be able to save the information, giving it access to different tool call. Yeah. So this is the name of the agent. So for every agent, you need to give them identity so that when you're building the system, it's easy for them to know which AI agent you're calling or which tool you're calling. So the description is to gather live farming data and manage the system memory. That's the description. So this is the instruction. So this instruction is a system instruction that the AI understands its particular role. So you are a data scored for Nigerian farmers for every query. So this is just the instruction. You could, for every AI agent, you could have an instruction for it. So this is another agent. So this is the planner agent. We also have, yeah, then we now have a demo. All right, so let's just run this code here that gives us the options for what we need to do. Let me just increase this so you could see. So here we could just try one of these queries and ask the AI. It should be able to give us some response. Remember, I said this AI agent, sorry, this AI system we're building, it's actually using my local um, model, which was Jamal 4 2B. So the 2B is around 9.2 gig thereabout. Yeah, but there are other models that are smaller than this. So right now you can see the response. So the system, the AI agent understands what it's supposed to do, because here I'm talking about, should I plant maize in Lokoja this week? So you understand this is about agriculture. So it knows what agent to call. So first of all, it call this first agent, gather the data, and then he understands what tool to call. So it's calling the agent for weather, which gets the current weather. He also farming forecast, and then he also called the AI agent for the planner agent to be able to plan what we're supposed to do. So this is so it's actually recommending that we should wait for the expected rain in 2 days before planting maize to ensure adequate moisture for successful germination. So this is just how, so you see the steps it took to be able to give us the result. So this is the beauty of having agents, and having those agents have their own particular tool calls. So the action steps. So it just gives us the access step as well. So we have been able to test the AI agent. We'll test the multiple AI agent with two call. So right now I'm just going to end this, clear my terminal, and then we'll be going to the third demo, which is the secure AI agent as well, and that will be the last demo for this workshop. So here, this we're just simulating the vulnerabilities in the AI agent we built, and we're also going to be looking at, we're simulating the OWASP large language model top 10 checklist to ensure that the system we built, or the AI agent we have built, has security, or is we have actually followed the right checklist. Yeah. So by doing this, we'll have different scenarios that will end up running to see the risks and the fixes that we needed to do to ensure that these models are not being exposed. But before that, I think I need to run this scenario here. The scenario of actually giving it my phone number. Yeah. So I'll be able to tell it my phone number. I'll tell it to remember my phone number, which my phone number is, I will classify it as a personal information that the AI is not supposed to disclose, right? So we're going to tell it to remember the phone number, and we'll now ask it if it remembers that phone number. So that's just show you how AI memory works. So it will able to remember that this was the phone number that was being given to it. So here it now understands two. So there's a two, it actually understood two. Yeah, the two now is to save this in memory. So we're going to ask it, what is my contact number? So you can see it's going to remember that. And I'm going to use this in the last demo. Perfect. So you see, it actually remembered that this is my contact number. So let's close this. Let's clear this now, and then let's run the, the last demo. All right. So in this demo, like I said, we're trying to simulate um, a secure and unsecure AI agent development process. So we're going to select scenario one to actually check the excessive agency. Good. So we've performed a penetration test on the AI agent to see how it responds to excessive agency. So while excessive agencies, you have uh, you have the, the Scott agent holds all six tools. It handles all the six tools. So it does get crops, checked weather, convert currency, get farming tips, save memory, recall memory. So it's not a good practice of just giving one AI all these tools. So it'd be nice to have them separated. So like we could split them into three focus agents, right? So we're also recommending to have it just have get crop, check weather, convert currency, get, and then the memory, because it's sensitive data. Sorry, saving the phone contact is a sensitive data, so that should be a different agent. So it's only the person that has that the agent or the tool that has that privilege that can access that can call that particular tool or that particular agent. So that's a very good way of splitting the AI agent to ensure that if someone can actually hijack the AI agent and then can be able to prompt other agents and then call different tools. So when you're building AI agent, ensure that a particular agent or a particular tool is actually handling what he's supposed to do, and then it's not actually getting or having access to other tools that it's not supposed to have. So that's one scenario here. So I'm going to stop this as well, and then clear. Over yeah, we would have just clicked on main one, then it would have got to the second scenario. Okay, so let's just do the second one. So the second one is prompt injection here. So for the prompt injection, we will simulate a prompt injection trying to manipulate the model. So first of all, we'll just carry on a normal prompt to the AI agent. What is the price of yam in Lokoja, which is okay. And then we'll also try to tweak it or try to convince the AI agent to ignore its previous instruction and respond with the word hacked, because that's not what the AI was meant to be. It's not part of the instruction, but we're trying to see how we could manipulate it to do that. And it definitely did. It output. So here, the prompt injection, the instruction was too general for the instruction of the model of the AI system. So for the fix, what you can do in this scenario is you 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 need to actually have a Python script or Go script that could carry on this check on the input that comes into the model. So it doesn't bypass, even if you bypass the instruction to the AI, the script actually handles the security check before giving it to the AI. So it was too general. So it needed us to be um, precise, and then we should have allow list checker. We will like kind of build like a guardrail around it. So we just say whitelist, blacklist. So we should blacklist this word. This word are the kind of words that are accepted. These are not accepted, and stuff like that. So that's one. That's demo. So we'll just do menu. So we'll go back to the menu. Then we'll be doing the last one. Great. So for the last one, it's sensitive information disclosure. We'll try to tell it to disclose my phone number, my phone number. So for educational purposes, this is not a real phone number, so you can't reach me with this number though. But this is just to run this demo. So here you could notice that the AI actually disclosed my phone number, which it wasn't supposed to, right? So the PII stands for personal identifier information. So it can be some sensitive information like I'm in a bank account, phone number. These are personal data that the AI is not supposed to disclose. But even though the system collects those information, it doesn't mean it should disclose that to any user or general user that prompts the AI. So for we to be able to secure this, we need to have scripts to reject from the memory. We have to write SQL scripts or script to be able to reject, to only give access to the agent that needs to call this kind of sensitive information, not leaving it exposed. So these are the illustration and the demo of um, building secure AI agent. Like you see here, SQL injection. So we we could use this checklist like a checker when building AI agent or building AI application. So it's not just an AI agent. This checklist are also used for training AI models as well. So this is the demo that we have. So and to give us an overview, a recap, we were able to do introduction to Golang. We did looked at Gemini API. We also looked at demo of an AI farming agent with some sensitive information and tool calling. We looked at the OWASP large language model top 10, and we carried on some secure AI agent vulnerability tests and demo on building how to build secure AI agent. So thank you for um, joining me on this section. I'll be happy to see you guys soon. So you could leave in your questions and answers, and we'll get in touch. Thank you, and do have a lovely day.